Howdy, howdy, and welcome to another episode of the Denver Green Living channel. I'm so excited today because I get to introduce you to Peter Stuart. He is the chief builder and owner of Sterling Builders. And we are going to be looking at something pretty exciting, which is the first multifamily passive house certified home in the state of Colorado. And so what we're going to do is Peter's going to walk around, show us that a little bit, and then we're also going to get to look at some of the photos of what all went into making this very cool home happen in Englewood, Colorado. But before we dive in there, I just want to say thanks so much, Peter, for joining us.
Pleased to be here.
Before we dive into talking about the house itself in Englewood, this passive house duplex, would you give a little intro on why you decided to go for passive house? I know you're a builder, you're a realtor, you own this business, and taking on a passive house project is a big deal. So what kind of motivated you to go that route?
Absolutely. I think that I oftentimes ask myself that exact question, and the answer is probably not a good one. But in general, we knew we wanted to build a house. We knew we wanted to build a passive house because, in my opinion, it is the highest building standard that you can build to. And I think there is something very beneficial to setting your goal as whatever the best and highest criteria are, and then working to get there. Myself personally, I don't really have any desire to build mediocre anything. Doesn't mean we're perfect. It doesn't mean we don't make lots of mistakes and redo lots of things. But we definitely wanted to set our sights as shooting as high as we could go. And I am fairly confident that passive houses is the best way to achieve that. So when we decided that we wanted to build a house, it was a pretty easy situation to say, yeah, we definitely need to do this passive. It's not the first house that I've built. I built a couple houses back in Maine and helped other contractors on a few out here as well. But we are mostly a higher end custom remodeling addition residential contractor. And we also do development is about 30% of our business.
And so you personally got certified or trained, I'm not sure what the correct wording is, as a passive house practitioner, and then brought that to your business?
Yep. So I actually did that about 3 weeks before COVID hit. I was in Seattle getting certified for passive house, and it was a lot of people that I had heard of and knew about. So it wasn't sort of jumping into a brand new world for me, but it was kind of fun to find the group of like-minded people who were really intrigued by the same things I was. And, sitting there for 4 days and sort of geeking out with other building nerds who wanted to discuss, the minutia of how to make this house perfect was a lot of fun. And I quickly realized that community, more than the building standard, but that community really does drive towards building high performance houses. And some people look at it in terms of greenhouses, and some people look at it in terms of high performance luxury houses. And they've all sort of converged on this passive house thing. And so it's kind of fun to look at both aspects of that and how it brings together the two different groups of people.
Yeah. Well, I was so excited when we met. I came to do the tour when it wasn't quite ready during the passive house tour days several weeks back. And yeah, my background is doing building energy efficiency and home energy ratings and energy modeling, and most realtors don't know what I'm talking about. So it was really cool when I happened upon all the stuff that you guys were doing. So I definitely wanted to make sure to share the story. So what we're talking about today is that this home, this building just went on the market. So there's two sides of the duplex, 3591 and 3593 South Ogden in Englewood, Colorado. So we put the links to their MLS listings if you want to check them out and go buy them. So you can definitely reach out to me. I'll set up a showing, but Peter is actually going to show us around a little bit, and then we're going to look at some of those other photos.
You got it. Real quick we do jump around here, I
Yeah.
always try to make sure I make this pitch before I do any sort of advertising for what we do. We did not invent this movement. I did not invent this movement. We happen to be the first certified going through certification house in Colorado and a lot of surrounding states. But this whole movement has been built off people working really hard to push energy efficiency and better building for the last 40, 50 years. It is not something new. There's just not been a great push to sort of converge the two worlds of high-end building with energy efficiency. And I think that is what is finally converging together. Passive House is doing a lot to help with that, but putting those two worlds together has created this thing that more people get involved with. We've had more builders and tradespeople through this house than I have potential buyers. Builders who've been building for 30 years and say, this is awesome. You know, what you're doing here is awesome. And I say, we're not the ones who started it. We are just sort of helping the two different industries go together and making sure that I do a quick shout out to everybody who's been doing home energy audits and solar and everything else for the last 30 years. It's been a grind for them, and I've watched plenty of people do it, and it's a lot of work, and it is finally starting to catch on. So we're just trying to jump in and help out on that train in any way we can.
Yeah. I mean, I was working on the Colorado home energy rating system I know that my daughter was a baby. She's now 33, 32, I guess. And so, 30 years ago, there were a lot of people working on this stuff and I got certified as a blower door operator and IR camera and worked at Fort Collins Utilities on some of their research. So, it's just really great to see the next evolution of it and, what all you're doing with it. And I wanted to mention too, we have another video that's coming up. I'm going to be interviewing Mariana with Emu Systems, and they are Passive House experts. So we'll be able to dive into a lot more of the details so that Peter won't have to feel like he has to explain everything about Passive House in this video. Explain whatever you want that relates to this, but it's a pretty complicated topic, and we just wanted to make sure that you knew Passive House is a thing. People are building them, and here's a couple that you can actually go see or maybe even go buy.
Absolutely. And the people at Emu, a quick shout out to them as well. They have been pushing this longer than I have, and I think they're finally starting to hit a critical mass. They're doing a ton of training. I think they're the largest trainer of Passive House tradespeople in the U.S. now, and they have more knowledge on the Passive House and performance building world than any group I have ever worked with. So they're the ones. Didn't inspire me to do this, but they kept me on it as we started. We worked with them on this whole project, and it would have been a nightmare had we not had them to sort of bounce ideas off of and work through all the details as we ran into them.
Yeah, and it's great that you're doing this in Colorado, and so anybody else in Colorado that wants to do this, we have access to these resources. All right, so should we take a look around?
Sounds great. I'll head all the way up to the third floor, and we can walk our way down. It's probably the best way to do it. Nobody wants to look at me for this, so we'll point this out. Yeah. One of the cool features that we got, we were actually initially going to start off, and we were looking at a 3-story solarium. Pretty quickly, it turned into something that wasn't going to work Passive House wise because there's too much exterior envelope. But we do have a chase here that runs up all 3 stories. Right there is an interstate highway, which we think is pretty cool. Sort of tests our building practices. If we can build here, we can build anywhere.
I was surprised how quiet that is. That's very quiet. Insane, because I know when I drove up, I was like, I don't know about this location. But you just totally forget about it once you're inside.
Yep. So that is our view of the mountains. You have from this porch, and I can go outside and you can see how loud it is outside. But if there's not too much glare, you got 180 degrees of mountains and buildings and construction. And highway all the way down there.
It is a little loud, but it's not like the Jim Carrey scene, you know, where you're like, oh,
Yep. It's sort of when you get the stoplights, you'll get packs of loudness where you can't hear anything.
Mm.
So those are our.
But definitely much quieter. Yeah, you notice it when the door's closed there.
Yep. When you pin that shut, it quickly becomes quiet. So up here it's kind of interesting. We did a lot of our mechanicals from the third floor down. So this room right here is our Zender ERV system. So this system right here is what circulates all the air through the house.
And just to say what an ERV is, so a energy recovery ventilator.
Yep, you got it. And basically what it is it's the lungs and the breathing apparatus for this house. When we build it as airtight as we do, it's important that we're not creating these stale, stagnant, nobody wants to live inside of a Ziploc bag. So this right here is what's constantly circulating air through the house so that you can maintain that clean air quality, but not be taking air from outside that's leaking in by itself. That's what we got there. And everybody,
that's how you're delivering fresh air, but you're not just venting out whatever the cool air or the hot air, the air that you just conditioned that you're.
Exactly.
So that's why it's called energy recovery ventilator. That's exactly what it's doing.
You got it. So it was sort of interesting. I've had a lot of questions on this. Everyone asks, well, why don't you do on-demand heat? Why don't you do tankless? Well, we don't have any gas in here, and electric on-demand heaters have a massive electrical draw, about 160 amp circuit required for them, which sort of defeats the purpose of trying to build an energy efficient house if it's using so much electricity that you're sort of adding more tax to the grid, which we are not trying to do.
So that was the water heater?
That was the water heater. It's a plastic tank, so it's a lifetime tank with titanium elements. So it's a commercial unit that actually will last for about 30 years. Not the.
Is it an electric heat pump water heater then?
It is not an electric heat pump. It is just electric resistance. And the reason we did that was to avoid having to make additional penetrations for a air source heat pump water heater, which would require us to do another compressor outside as well.
Gotcha.
Yeah. Third floor bedroom here. It's got every bedroom here has its own bathroom. All the exciting features here in terms of a standard house. We have a closet here. These features are nice. They're not the most exciting in terms of building science, but they sure are nice.
And so the total numbers of bedrooms, bathrooms, square footage, and maybe say the price as well.
You got it. So each unit is 2,854 square feet. We have 4.5 bathrooms on each side and 4 bedrooms. And then the units are listed right now at 1.675 a side. And yeah, we're actually testing out our electrical usage right now, trying to figure out if we can get an accurate read before we sell them as to how much energy these are using. I don't know that we're going to be able to through construction, but we're giving it a shot.
Right.
Second bedroom here.
Did you end up going with solar on the roof of these, or what did you end up doing for all that?
Yeah, we did not. And we're waiting to figure out the usage that we get out of the building before we would put it on. It's pre-wired for solar on top of the garage, and it's set up to accept that nicely. So we're excited to see how much energy somebody actually uses here.
Right, that makes sense.
Yeah. Second bathroom here. Did lots of cool features here, like floating all of our vanities. So all of our bathroom vanities are lifted up off the floor, and they have lights that turn on underneath them, which is a pretty cool feature at night. It's fairly ineffective during the day and when they're off, but details like that, just trying to set this apart a little bit from a standard house. Real quick in here, I think everybody's seen washer dryers before. Being that we are trying to get a ton of air tightness here, this is actually not a standard dryer, it's a condensing dryer, which I think a lot of people have seen and heard about. this is the first one I've seen that's full sized. So we're excited to see how these work rather than taking all of the hot air and dumping it outside with a bunch of energy. It's actually got a small little drain line right here, and it's condensing that water down and then dumping the water down the drain so that there's no dryer vent required on this house, which is a pretty cool feature and definitely helps.
Wow. That's amazing. I didn't realize that was one of the things that condensing, yeah, because it just seems like it is a big hole in the wall, but heat is going out. And also the whole thing with all the lint and everything.
Absolutely. It's a 4-inch hole that's continuously open inside of your house. And it has to be, because you can't block it off with anything because the lint will get stuck on that. So
right.
Standard house has a 4-inch hole letting air in and out all the time. Got a closet here. We went big in the primary closet, lots of room. We actually, in our initial designs, we had it about 12 feet long. I think we extended it out to 14 and a half feet because we wanted to make sure it was large enough.
I know that when I did the tour, there was like a little kid that was like going in one side of the closet and then coming out the other.
That's the one on the 3rd floor.
Oh, okay.
So in that room we saw on the 3rd floor, there's some lower headroom space, so we just made it a closet. And yeah, it's a pretty fun little closet to run through.
Yeah, they definitely, the kids definitely like that.
So this one here, we're playing with a bunch of different views on light here. So in this primary bathroom, this is an entire wet room, so we have glass that's getting installed across here. Tub is in the wet room. You have 3 shower heads. And it's fully enclosed. And then in order to make sure we didn't create a cave here, we actually opened up a frosted window into the stairway. So you get some privacy, but you still get all that light
from the stairwell.
Stairwell shaft that goes up and down the middle. And then in addition to that, we did this feature here, which is a skylight all the way through the 3rd floor. And that provides a ton of natural light for this whole bathroom. So we don't have any lights on in here during the whole day. It's more bright in here than you would ever need it to be. So more handiwork, lights.
How does that work then, Peter? So like is it basically open? Like, do you have like a ventilation fan in the bathroom, or how does that?
So we don't have a ventilation fan. We just have the whole house is circulated with that ERV system. So we have these fans, which in all of our bathrooms, it's sucking air out. And then it's actually kind of cool little feature. People ask, well, how do you, if you take a shower, how do you get the steam out? You actually just push this button right here and it boosts the ERV system. So it ramps up. I think it usually runs at about 30%. This ramps it up to 100. I don't know if you can hear that, but there's a little hum. And that's it running at full speed. Barely. It's not even nearly as loud as a bath fan, but it fires up and it actually circulates the air through the house everywhere at a much higher rate.
So with the ERV, are there these fans kind of throughout the house then?
There are. I'll show you a couple more.
Okay.
So you've got this is the closet, and we've got
ECM motors, like the electric commutated motors. So that's why they're so quiet and so efficient?
I think you're right. I would always call anyone at EMU and ask them that question.
Okay.
They're more knowledgeable about it than I am. But
I remember doing some research on that when I was at Source.
They are very quiet though.
Mm-hmm.
So this is a wall register here, and I can actually, there's a pretty good stream of air coming out here. This is fresh air being circulated through. So that dirty air from the bathroom is getting sucked out right now at a higher rate, and fresh air is getting pumped into the bedrooms.
Gotcha.
Different from all of our heating and cooling, which is coming out of these registers. So you've sort of got,
so it's two separate. So the heating and cooling are separate systems, or compared to the ventilation.
Exactly. And this is the primary bedroom here. We've got lots of space. We've got a building that could only be 19 and a half feet wide. So we sort of took advantage of ends of the building and tried to reduce hallway space as much as possible. So this is the only real hallway that we have in the whole house.
Yeah, it is a very interesting building to make it a duplex because it's pretty tall
Yep.
and narrow for. And so, did you do the design of this, or who kind of
Yeah,
crafted the
so
design?
we worked with a team out here, Steve Scribner and Morgan Law at Shape Architecture, and they helped us with the initial designs. They both have done a lot of passive house work, and they helped us with initial designs, and then we sort of worked with another team as well on a lot of the finishes. But they came up with a lot of these features. So in terms of general design and building structure, they came up with most of that.
And when you were saying like your idea of an atrium or a solarium, what was the main reason that that didn't work as a passive house? Was it the
That's a
amount of like sun gain, or was it the air ceiling, or kind of both?
Yeah, so that would, and what we're talking about is this. So this central shaft in the house that goes all the way up. I think it was multifaceted, but I think the majority of it was that we had a lot of glazing that was not facing south. So we were sort of dealing with this very large surface of glazing that was not intentional. It wasn't put there for efficiency. It was put there for this cool look, but it wasn't completing all of the criteria that we were asking for from it. So it looked cool. The other thing that happened is that if we took this whole area out, we created this very small walking space over here to get through, and it really did break the house up into front and back, which we didn't like.
Right. Yeah. Cool.
Yeah.
Well,
down on the first floor.
Thank you. Well, I know also, I think the other thing I wanted to ask you about was, I think there's different ways to go to really focus on the whole energy efficiency piece. And I remember an interview that Paul Kreischer did with Gene Myers of Thrive Builders, and he was saying, we aren't doing like quote unquote affordable housing. Like I commend people that are, but that's not our market. Is higher end is kind of what Thrive was doing, higher end of production builders. So I was just kind of wondering, when you chose to do this price point and some of these finishes that you have, what was your, I know you mentioned high performance, but what was your idea of focusing in this kind of this price range?
Yeah. So this is one of the things that we had going for us, is that we were doing this all internally. So we were not, we didn't have anybody involved in decision making. My uncle and I are actually partnered on this, and between the two of us, we sort of doubled down and looked at it. Okay, we're gonna build this. The other 70% of my business is higher end custom residential remodels. That's what we do. That's sort of every decision we make is, should we do this? This is the cheap way. This is the right way. We always choose the right way. So I sort of knew if we were going to spend that much time and energy on the details behind the wall, we had to make everything match on the surface. And that was really what we were trying to do, was to show this is not, if you want to live in a greenhouse, make it really, really small. Make it really, really simple. Make it a cube. It's the easiest way to do it. We tried to sort of show that you can have both. You can have performance, you can have luxury in the same house. And I think from here, you can't do a whole lot more in terms of finishes. There is another tier for sure, in the $7 to $12 million house range. But until you get to that, we sort of maxed out, finishes. We've got Brizo faucets, this dolomite, which is a type of marble in the kitchen, is very expensive, very gorgeous. And we wanted to make sure that people didn't come in here and think, oh yeah, it's green, but green just means I'm feeling good and saving the planet. We like that. That is what drives us. We also want to show people this doesn't have to be a Prius. This can be as fancy as you want. Being passive house doesn't mean your house has to be boring. It doesn't have to be basic. You can put those two things together.
Yeah.
So.
that's interesting. And so, and maybe we could start looking at some of the photos now, if you want to.
Absolutely.
Or did you want to take a peek from outside so people could see kind of what it looks like from the front, maybe?
Absolutely. Let me walk out here. Now there's the noise.
Yeah.
So that's the front of the house. What we were able to do, we were going to do a basement and it didn't work out structurally, so we actually just dropped our first floor 5 feet down. So we were able to meet our building requirements of a 32-foot building, but we were able to get an additional 5 feet out of it. So that's why this building looks so tall in comparison to all the other buildings on the street here. It's our favorite highway.
That is interesting.
Yeah, and that's what this little retaining wall is that we put in over here. That was
right.
to hold back dirt to actually be sunken into the ground here.
So that might have improved your, well, I mean, I guess a basement would also improve it, but you have a little bit of ground surrounding it. I forget what you call that.
Yeah, absolutely. And again, when it came down to it, it's not, we still insulated basically the same along the whole building. We didn't worry too much about reducing insulation below grade. We knew we wanted to insulate well everywhere.
Yeah. Yeah. So let's go ahead and look at some of the photos. I know that when I was there touring the building, the one number that really stuck in my head, which you're probably going to say, but was the idea that the building codes were requiring, or I'm not sure if they were building codes required at the time you started, but the 3 air changes per hour at, in the conditions where you're doing the blower door test, and that your home came in like around 1/10 of that.
You got it. And I will share my screen if you're ready for it, and I can talk a little bit about those.
Yeah, go for it.
Perfect. So can you see what I'm looking at here?
Yeah, we can see the photos.
Wonderful. Great. So real quick, I'll just go in which the order the photos are placed here to make it easy. But this is our ERV machine. This is the actual unit. Units next to it are the mufflers. So this is part of what helps keep this unit quiet. There's not a lot to these units. In terms of a heat exchanger, it's not new technology. They just don't usually put them in residential houses. So that is that's one of the cool parts here. We didn't have to invent a machine to do what we wanted. They have existed for decades. They just aren't often put in residential housing units.
Right.
Exterior insulation. So our getting back to the number that you were talking about, we did on this house on our final blower door, we did 0.28 ACH 50, which is air changes per hour at 50 pascals. So the easiest way to think about it is you turn on your attic fan, which is probably gonna get you more than 50 pascals, but we're turning on somebody's attic fan and we're testing how much air is moving through that house based off of the volume of the house. So air changes per hour, 1 air change per hour would mean if you pressurized your house, you would get the entire volume of air in your house in 1 hour to turn over. So that is a current code built house is 3 ACH 50. And what we hit was 0.28. So just under 0.3, just over 10 times more airtight. And we did so with a lot of liquid flashing on the exterior zip, a lot of taping, and a lot of attention to detail, testing, retaping, smoke testing, air testing. We didn't just say, okay, here's a system, let's use it, and let's do the best we can. We chose a system, we tested it, we found issues, we went from there. So our first blower door score was 0.59 or 0.58. So between when we initially had our envelope we took half of the air leakage out of the building, based off of smoke testing, trial and error, finding mistakes, finding spots that framers had ripped the tape, finding spots that windows weren't shutting properly, all sorts of stuff like that. Going through and double checking is how we were able to get that number down.
And I think that's what you were saying was kind of the difference between some of the other home energy rating systems, like people might have heard of LEED or Energy Star, or, they're built green, like kind of depending where you live. But my understanding is that Passive House, the difference is that you have to actually be measuring the performance of the built system rather than just, and that's funny too, because with my home energy rating background, we saw the problems of calculating it, modeling it, and then the real buildings were different, and kind of the issues that came up there.
Absolutely. The example I've used a couple times with people, and again, if anybody's taken chemistry in high school or in college or has ever done science experiments. So when we get to a higher level of chemistry, oftentimes we do labs and our grade would be based off of the yield you get. So you'd be trying to do this chemical reaction and you'd need to get 5 grams of some chemical out of it. And if you got 4.8 grams, you'd get this certain grade. And if you got 0, you'd get a 0. Passive House is exactly that. So we're actually getting a grade based off of the performance of the building. This is not getting a grade for showing up to class and doing a great job learning. It is saying we're actually going to measure what you've got here. And if you didn't get what we asked you to get, one, either you can't certify or you switch to a different level of certification. But it is a pass fail with a very high standard of that 0.6 ACH 50. So most buildings couldn't just say, oh, I'd like to be Passive House certified. I would guess that probably 0 buildings without the intentional thought of getting to that number would achieve that. I know there's some people, builders who do a lot of marketing and builders on YouTube. They'll say, oh, we got it in the ICF house, which is a insulated concrete form. Types of houses like that. If you don't plan for it, you don't get that. You'll get 1 or 2 or 3, but it does take excessive attention to detail to get a number that low.
And I know that also, I know somebody that does a lot of work with building energy codes, and she was saying, builders are complaining that how am I supposed to get to 3? And so, just hearing these numbers, you might think, oh, 0.6, 0.3, like whatever, no big deal. But it's not necessarily going to happen, even if you buy a brand new home that, has some stickers on it. So that's what I think is exciting. And so, let's keep I wanted to know a little bit more details too about what levels of insulation you used in different parts.
You got it. Yeah. So I'll real quick, on this last photo, we have XPS insulation below grade here. And so that insulation is about 2 inches R5 per inch, so about R10 below grade. And then above grade, we used EPS insulation on the exterior of our building. That's that white stuff that coffee cups are made out of, the little white balls that go everywhere when you cut it. That is about 7.7. So in terms of our exterior insulation, we're roughly about 8.5 if you average it out. For additional R value outside of where you standard, where in general you would insulate a house. Most of the time houses are insulated sort of between the structure. We're actually wrapping a blanket around the whole house of insulation. I've got a couple of photos of that here in a second.
Okay.
Yeah. This right here, which is pretty cool, the slab that I am standing on right now, this slab on grade term, is generally done with concrete. There is no concrete slab underneath us. This is plumbing that you can see here. We've got all of our water lines in, and you've got a structural footer on the sides, and you've got a structural wall, concrete wall that's holding dirt back here. All of this then gets filled with plastic, which is air sealed, and foam. So there's actually 6 inches of foam underneath here. I've showed a lot of people this photo. And they say, yeah, well, you put concrete on top of that, right? I said, no, there's no concrete on top of that. There's actually 2 layers of So it is a floating wooden slab on top of insulation.
That is wild. So that reduces your concrete use too.
Massively.
Which, like, for people who aren't familiar with that, concrete is one of the biggest carbon emitters. That whole process of creating concrete. So to just totally skip that, that's insane. That's really cool.
Yeah, there's also I actually went to it was a Crossroads Building Symposium here in Denver a couple of months ago. Steve Basic and Peter Yost put it on, and this is actually a detail that Steve Basic came up with and sort of termed here in the States. I think it's been used around the world a lot, but this slabless slab detail that he came up with, it prevents a ton of moisture entering your building because concrete is releasing moisture for the first 2 to 3 years of its life. And so if you have this highly sealed house and you're dropping a ton of concrete into it, 4 inches thick across 1,000 square feet, you have moisture entering your building continuously. That concrete dries. So this sort of solves a variety of problems, all with one simple swap out. So don't do concrete, air seal plastic, put 20 mil of plastic down, do 6 inches of foam, and then put plywood directly on top of it. If you walked in this house and you have nobody ever asked, well, is the floor moving around? It doesn't. This is actually rated. Foam is rated for crawl spaces. It's rated to go under concrete. And so it's able to hold a ton of force when you spread it out across the plywood above it.
I think the other thing, and you can keep going with your photos if you want. I think the other thing that you mentioned when I was doing the tour was the idea that what you really don't want to do is partial passive house. And,
yes.
And I think that's like partial, anything like this because of this idea of sealing things so tightly, that all has to be like a really integrated system design. You can't just, if you go into a house that was built in the 60s or 70s, you go add insulation and air sealing, you might very well be backdrafting your water heater and
absolutely,
could kill your occupants because of carbon monoxide. So the idea of just going and adding insulation and air sealing without an integrated approach, you definitely don't want to do that. So just like that as a cautionary tale for existing homes, but I think even for new home design, what you were saying was like you can't just go kind of halfway.
No, the example I probably use is when we did the open house passive days as well. If you took a Tesla, and it's sort of a similar analogy to what we've got here, being that it's all electric, it's high performance. If you took a Tesla and you made it go 0 to 60 in 2.6 seconds, but you put Honda Civic brakes on it, people would get hurt. And there's a good reason why when you engineer this stuff, you have to finish it off. You have to, when you put triple pane airtight windows, you are needing to account for the fact that now you don't have drying potential through air leakage through these windows. Colorado is super dry, and we are able to get away with a lot of issues, leaks and stuff, because it just dries to the outside. When we seal this stuff all up, we have to intentionally plan for that. A lot of these walls in this house actually dry to the inside. And if we are now coming in and putting on vinyl wallpaper, we now just sealed that wall and now it can't dry to the inside. So we said, okay, we're gonna make this great wall that is accounting for moisture, and it's a great wall thermally. All of these things are completely negated if you don't follow through with that and take it to completion and say, okay, where is the moisture going? It needs to get from this side of the wall all the way through to the other, and nothing can get in its way. A lot of times that happens. If you say, oh, I want an airtight house. Great. You want an airtight house. How are we going to make sure that air is still exchanging through this house so that it is a comfortable, healthy, safe house to live in?
Right. That air and moisture are considered in that whole thing. Yeah. When I was doing some of the work with Fort Collins Utilities, what we, I was just kind of a research grunt, like I wasn't doing the main stuff there. But one of the things that the data showed was that the duct leakage in Colorado is amongst the highest compared to anywhere else. And it's because if you did that kind of duct leakage in Minnesota, your pipes would freeze and you'd have issues. If you did that kind of duct leakage in Florida, you'd get mold. But Colorado is just kind of like, it's fine. And so, yeah, so that's part of it, is that if you're using what you standard building techniques, especially for Colorado, are built on the idea that this, based on the forgiving climate, that lets us get away with things.
Absolutely. Yeah, absolutely. I've spoken with plenty of builders who say, well, why, this type of building science isn't needed in Colorado. It's not like buildings are falling apart and causing trouble out here. We get away with a lot. They're probably not wrong in terms of that fact, but they are wrong that if we have a better way to build and we're not using it, that is, that's shame on us. If we have got the technology and we've got the knowledge and the skilled tradespeople to do this, there is absolutely no reason to be building subpar houses because we can get away with it. I mean, there is the building stock that we're building now, if we build it right, will last for the next 150 years. And so we're not just building for now. We're not building for profit. We're not building for the rest of it. We're building to have buildings that are around for the next 5 generations. And I think a lot of people forget about that here, because you can forget about it, sell these houses quick, move on.
I think someone's at my door. So I'm going to mute this, but I'll let you keep going. So we'll want to kind of cruise through here.
You got it. I'll cruise.
Okay.
Perfect. So the next thing that we're looking at here, this is a heat pump, air source heat pump. So a lot of those units that people are used to seeing on a hotel wall, the big cassettes that are very ugly, we have all the same technology that they have here. We just wanted to make sure that they were hidden. So we actually, if I can show you in person, that right there is the unit that we have shown here pre-framing. So that unit is completely concealed inside the building so that you don't have to look at it. So you get all the energy efficiency. These are 23 SEER units without having to deal with looking at this hideous big white plastic box.
23 SEER. Wow.
23 SEER. You got it.
Amazing.
Yeah. So then we come to, this is the east face of the building. This is our EPS insulation. People always are asking, well, why'd you do that one? Well, we tried to get rock wool insulation that was on our initial plan, and it was 7 months out. So it was a supply chain issue. And we calculated for the change with all of our insulation and put it into our model. And the people at EMU said that we were good to go to do it. So we wrapped around all of our windows first, and then we came back in and filled the field with exterior foam.
So so the EPS, extruded polystyrene, I think. So is there insulation on the inside as well?
There sure is.
In the joist spaces. So the typical. So is that like R19 or something like that?
Yeah, I think we have like about R26 in there. It is a dense packed fiberglass blown in insulation. So you're taking sort of standard blown in, and you're about twice the density, I think, in terms of the insulation you're putting in there. If you go too high, you're actually reducing your insulation value. If you go too low, you're reducing it. So we try to hit that sweet spot of getting maximum R value per inch. But the ceilings and all of the walls are blown in fiberglass, dense packed.
Gotcha.
And then on top of, you can see the last little corner there of that EPS insulation. On top of that, we did a WRB membrane, which is a weather resistant barrier or water resistant barrier. All of the rainwater, if you took a hose and sprayed the house, that bulk water is caught by this membrane and actually drains down the surface of the building through these battens and then out at the bottom. What that allows is it allows water to get out, and it also allows air, as the air heats up, it rises up through those cavities and pulls a lot of moisture with it. So if the siding gets wet, it dries out very quickly. So that's one of the huge benefits of having your siding on a rain screen is you don't have to deal with rot. Ours is not painted, but if it was painted, you don't have to deal with paint peeling. Most of the issues with siding happen actually on the back side of the siding rather than on the front side, because the front side can dry. It's open to the air.
Oh, interesting.
Is what generally rots out.
I wonder too, like, I mean, just in this last couple weeks where we've had record high temperatures, record breaking, but also like last night, I'm not sure how we had an inch of rain in an hour. That's my guess, just because there was an inch in one of the pots out there.
Yep.
But as weather starts getting more extreme with high temperatures, temperature variations, amount of that, the warmer climate then holds more moisture, so more moisture can drop in a shorter amount of time. So building into it that kind of resilience seems like a good idea.
We're in a pretty good, I mean, the business model here is very sound. Let's just hypothetically say the climate in Colorado was to change even a very, very small amount. These buildings that we've been building for the last 40 years, this issue we were talking about before, where you can get away with stuff here, pretty soon you won't be able to get away with it. And as soon as you can't get away with it anymore, let's say that the amount of moisture increases. Let's say it decreases. Let's say that it decreases and we have a lot more fires than we already have. All of this building science is going to all of a sudden become very important. People are going to say, well, I don't want smoke in my house. How do I have a house that has a system in it that filters air? I can't open my windows when it's smoky outside and I've got all this forest fire smoke coming into my house. We've addressed all that on the front end. So that's one of the big reasons that pushes me to make sure that all the houses we build, at least, are sort of future-proofed, for lack of a better word.
Yeah, that's somebody else I interviewed, Christine, who put an air source heat pump. They said that was one of the big things was during those smoky days that they suddenly had, an air system that could keep it clean. I'm wondering too, what about fire resistance of the materials that you chose?
Yeah, so the majority of the time we didn't spend almost any time worrying about fire here. We are in the middle of a city. Our biggest fire risk is probably a car burning on the street or the neighbor's house burning. We're not really worried about forest fires here. We did pick a metal siding, so the roof and all of our north and south facing walls have 24 gauge standing seam metal on them. So that is fairly fire resistant. The majority of the issues when it comes to fires are actually embers getting sucked up into an attic space. And in this house, we don't have an attic space at all. There is no vented attic in here where that cold gets drawn through the soffits and the hot air goes out the ridge. So this house would survive very nicely in fire rated zones. We probably wouldn't have put wood siding on the front and back of it if we were in the, in a high fire risk area. But in general, the building science behind this, being that it's airtight, we don't have air getting sucked in to this building all over the place. And we don't have air coming into our attic because it's a completely sealed attic, unvented.
Yeah, that makes sense.
Yeah. And actually, this is a perfect picture of that. This is the skylight on the north unit there. You can see that vertical lip right here. That is all dense packed insulation. Got about R86, I think, when you the calculation in that roof there, and on average. And that is a huge part of fire resistance, is not having embers getting sucked through there. And then it's also energy performance, having this hat on the building. So if you're trying to bundle up for the cold, the first thing you do is put a hat on. That's what we have here. So all that heat that would rise through the stack effect and try to get out your attic, we air sealed it, and then we added a lot of insulation so that it keeps that heat in. It also does a great job of keeping it cool in the summer because you have your roofing above it. It gets very hot up there. You're just pounded with sun, and we're trying to keep all of that heat out during the summer and not creating that third floor to become a sauna.
And then your the windows, what did you do as far as what did you do for going with the windows?
Yeah, so we did all of the windows that we have in our walls here are Alpin, and then all of our skylights or roof windows are from Lamelux, which is a German company, I'm fairly sure. So we ship those in through 475 high performance building products. Those are triple pane, and all of our windows are triple pane as well. Windows were made here locally, and it's sort of interesting. We did, people at EMU can speak to this more than I can, but we did high solar gain glass. So a lot of people think, okay, well, I really want to keep, especially now in summer, I want to keep my house cool. I want to keep all that sun out. We are still a heating dominated climate. So we spend more days heating our houses here in Colorado than we do cooling them. So if we want to get our overall yearly energy usage down, we need to be gaining as much heat from the sun as we can rather than rejecting it. So we all of these windows here have a film on them that gains as much radiant heat from the sun as possible to keep our building warm.
Interesting, right? Because the coefficient of performance of the heat pumps, it's more efficient to cool than it is to create heat.
Absolutely.
So if you've got the heat, you can remove it more efficiently than creating heat, probably. I'm not sure if I said that right, but I think
you got the right principle for sure.
Yeah.
So this here, just another picture. All of this is tape. So we're taping all of our membranes together. It's an acrylic-based tape, and it's the stickiest stuff you've ever seen. It's a lot stickier than duct tape. That's how we got a lot of our air-sealed barriers. This is actually on the outside of that, but this same tape was used all through the building to seal up any spot where you would have air leakage and to seal that interior white membrane that we saw in the skylight photo.
Right.
This is us, same thing. It's completed on the backside. That is the part of the house that matters. Everything outside of that, this rain screen is really just pretty, and it keeps some of the water off the house. But you could probably leave the building just like that with that membrane. It's UV rated. They don't want it as exposed as it currently is, but in theory, you could leave this membrane. That's what's keeping the water off. The air sealing is done behind that. And then everything we put on the front is just house jewelry. It doesn't have to be there, but it does make it pretty.
So in traditional construction, instead of this pretty complex system that you have here, we're just talking about the wrap. Like, is the wrap trying to do what all this is doing normally?
It is. It's kind of hard to compare them apples to apples, but in a general building, you'd have a 2x6 framed wall. You'd have OSB, which is oriented strand board, just regular looking plywood, and then you'd have Tyvek or something of a similar home wrap. That home wrap is perforated, so it's got little holes through it that are supposed to let moisture transfer through. It's not very well sealed. It's not very well taped, but it's just trying to, in general, keep the water from getting through. It has unintended consequences, though, because it oftentimes keeps the backside of your siding wet. It oftentimes keeps moisture in when really you'd like that moisture to get out. It's not a bad product at all. It just is oftentimes abused. And if you use it properly and you plan for it and you flash around your windows properly, there's nothing really wrong with it. It has built most buildings in the United States for several decades, but it doesn't achieve. We have exterior insulation, we have water membrane on the outside, we have an air barrier on the inside. It doesn't achieve any of that almost at all when you have one barrier that's stuck right behind your siding and then your siding is nailed to it.
Mm-hmm. Yeah, and I think that's kind of what we keep coming back to is this integrated design, and that all the parts and pieces need to work together.
Yep.
So do we have just a couple more?
Yeah, absolutely. I'll keep it quick. So real quickly, this is just after the whole house is insulated. So you look around, you got insulation everywhere. There's insulation under the floor. We insulated between all of our floors. That is not for energy performance. That's just for comfort and sound. This is our roof. So all of this dense packed fiberglass that is behind this Intello membrane has been blown in, And then everything on the surface here was another 3.5 inches of blown in. And that was to allow for a service cavity to run electrical lights, ERV tubes, all sorts of stuff like that, so that we didn't have to puncture this membrane when we wanted to get all of our different mechanical through the house.
Mm-hmm. So some different layers there.
Lots of layers on a passive house. And again, just the exterior as the siding is going on. Nothing too exciting there. And I think that's it. So this is sort of, as you can see from what we saw today, this was just the beginning stages of that, and everything else sort of came together from there.
Mm-hmm.
So that's what we got for photos. I'll close this down and I'll kick the screen back over to you.
Yeah. Well, thank you so much for doing that. I think that, it's rare for people to get to have an inside look at a passive house. And so were you saying, Peter, that the other passive house homes in Colorado, they were all single family? Is that right? And so this is the first, as a duplex, the first multifamily.
Yeah, and not to like split hairs here, but there is PHI and then there's FIAS. There's two different organizations. The organization that we certified with, I think, has 7 certified homes. They're all single family, and there's a couple of commercial buildings. Between both these certifying bodies, there are no multifamily. So no houses where there are 2 or more buildings connected.
Gotcha. Yeah. Yeah. Very cool. So what, okay, so just kind of as a wrap up for everyone. So this duplex, the 2 units, 3591 and 3593 South Ogden, are on the MLS. They're for sale right now in Englewood, Colorado. And so if you want to take a look, then give me a call, give Peter a call. Let's get you in there. And I love what you were saying, like different people are going, hey, this, like you think of it one way and somebody else is going, oh, this would be a nice second house. And you're like, wait a minute, we want somebody who like really uses it so that we can see how little energy it actually uses.
Yeah, the real estate side of me is trying to sell these, and that is our intention. We are trying to sell these units, and we are trying to get people in here to live in them. At the same time, I am very committed to this, and I want to tell as many people as will listen. So if anybody would like to come see this house and set up a showing, they can call me directly. They can work with their agent. They can work with you to come see it. I am not saying, oh, you don't want to buy it, get out of here. I want as many people to come see what's possible to spread the word.
Right.
That's very intentional. So anyone who wants to come see it, whether they like passive house, if they hate passive house and they think this is a terrible idea, come see it, talk about it.
Right. Right. And so if somebody is considering, let's say, we're talking to a builder that is considering building a passive house.
Yep.
What would be your 2 cents worth if they're like, all right, this Peter guy did this, I wonder if I should do it? What would you tell them?
Yeah, so it's actually funny you say that. The last guy I had walk through here is a builder. He's a custom home builder here in Englewood and in Cherry Hills Village, and he builds 7,000.
This is not hypothetical.
It's not hypothetical. I've had more builders and tradespeople walk through here than I have purchasers, and so they have. Everybody has said this is obvious. This is a no-brainer. If I'm going to build standard housing, this is a big deal in low-income housing because you can keep energy usage down. I'm going to build standard housing, affordable housing, low-energy housing, luxury housing for a 10 to 15% premium. I can't afford to not do it. Now that number isn't saying, oh, if you take a garbage house and add 15% to it, it's a passive house. No. If you're building high quality housing, passive house is something that should absolutely be put into it. There's absolutely no reason to not be building in building science. It's just, if you're going to build anything, think about it. Come up with a system, practice that system, test that system. It's a no-brainer to every builder I've talked with. There's some who are a little bit hesitant to jump on board because it's this new science thing, which scares a lot of people. But other than that, the majority of people who have seen this, almost everybody I've talked to have sort of tried to figure out what they need to know and what they need to learn to be able to jump on board and start implementing this into their current business model.
Because I would think that really what they would see is like all the solutions to the things that plague them. You
Yeah.
know, it's like, all right, let me just go ahead with the ERV and let me, get off of gas
Yep.
and, all these different things that they're having to manage the lifetime of the siding and different moisture problems. Like this has got it all in there, and the fact that you're really testing it.
Testing it and documenting it. It would, if anybody wants to see the internal bones of this house, there are thousands and thousands of photographs of it, which is different than most builders. You wouldn't know what's behind your walls. This is all public knowledge. Anyone who wants to see it can.
Yeah. It reminds me when I was at eSource, one of my favorite conferences to go to was the building commissioning conference. Okay. Because people would show these photos of like, here's this big duct entry and it says clean monthly. And then there's a pipe, like this huge pipe going right in front of it. So you can never open the door.
Nope.
So,
but
when I was doing in that building commissioning world, I understood that, buildings are complicated and a lot of things don't get built properly. And it was, so the whole idea of commissioning is let's actually get in there and test things and retest over time and as things change. And that's where the magic happens, because it's really what's actually happening. It's not our energy model. And
right.
even climate models, a lot of people are saying now, wow, we underestimated how quickly things are changing. And a lot of this you can't really know until you have the actual thing, so like the actual home.
Absolutely.
Yeah, that's great. And I love that it's a community. I think that's the other thing that people, we're all in this together, on the planet. And
whether we want to be or not.
Right. There's no competition here, really. Like it's something that we all need to figure out how to do things better. Us as realtors, to bring up the conversations. My thing I've been saying lately is like, did your realtor say, hey, you're going to buy this home, but could you also make it net zero? Like, like let's think outside the box and go as far as we can.
Yep.
In every transaction, every step of the way. And you've definitely done that here. So I commend you, and excited to see what all you do next, and hope we can interview the folks that are doing it affordable and, like small, tiny homes and everything else.
Absolutely. It's a realm that can be done on any spectrum. You can build a tiny house. You can build an apartment above your garage, passive. And I'm excited to see where the building industry starts to take that as it starts to become more of a mainstream code required building principle.
And I think the last thing that I wanted to share was something that you had said, was that, there is a learning curve.
Yes.
And so if you can design a project where you have the, I don't know if luxury is the right word, but where you have the leeway to spend more time, spend more money, do more testing, learn more, that is going to be a better way to do it, rather than trying to slap it on to a very tight time schedule and tight budget, when you're really going to be like getting a degree in passive house. It's a completely different thing. You have to really learn a lot.
Absolutely. We very intentionally built this house spec because we knew we were not ready to take this product to a client directly. We were way over our time frame. We were way over our budget. And that is the risk that we took. The product that we ended up with was exactly, if not more than what we wanted, because that was our goal. Our goal and our requirement was that we create a certified passive house that is high performance. And yeah, it cost way more money than we expected. And yeah, it took way longer than we expected, but we're pretty happy with the result that we got.
And yeah, and it's a learning process. So it's like if you had a manufacturing company, you're kind of retooling.
Yeah.
And that does require a lot of effort. So kudos for diving in and going through all that, and for sharing that all with us.
Well, thank you. I appreciate the interest, and we want to get the word out to as many people as possible.
Yeah, for sure. All right. And so then remember, we've got another video coming up with Mariana Pickering. Did I say the last name right? With EMU. And she's going to be talking about passive house construction. So we'll get into a bit more of it there if you want to know more. All right. So thanks, everybody. Thanks for tuning in. And if you're looking for a home in Denver and you want to go that extra mile, do something that your kids are like, wow, you actually care about our future, we like that, then definitely reach out. And thank you so much, Peter. And we'll sign off.
Thank you.
Okay. Bye.